All right, let's talk about two really important pieces of electrical gear that honestly get mixed up all the time, the Megger and the earthing tester. Now, they both measure resistance, right? But here's the thing. They're answering two totally different safety questions, and getting them confused, that's not just a simple mistake. It can be downright dangerous. So let's really dig into what makes them tick. I mean, think about it for a second. How do you actually test a safety system that you can't even see? The stuff that keeps us all safe from electricity, like the plastic coating on a wire or the grounding system buried under a building. We just trust they're working every single day. But how do we know? Well, that's exactly the problem these two gadgets were invented to solve. So here they are, and yeah, at first glance, they look kind of similar, don't they? They're both basically boxes with some probes, and they both spit out a reading in ohms. But what they're actually testing and how they're testing it, well, that couldn't be more different. So let's jump in and start with the first one. Okay, first up is the Megger. And a good way to think about this one is to picture it as a detective, an insulation investigator. Its entire job, its whole reason for being, is to check the quality of an electrical system's protective skin. So what does it do? Well, think of the insulation on a wire, kind of like a raincoat. Its one and only job is to keep the electricity safely inside. The Megger, then, is the tool you grab to find out if that raincoat has any tiny holes or weak spots. Places where electricity could leak out and cause a whole lot of trouble. So how does it pull this off? It's pretty clever, actually. First, it zaps the system with a really high DC voltage. We're talking way, way higher than what the system normally handles. It's kind of like pressure testing that raincoat to see if it'll burst. Then it carefully measures to see if even a tiny bit of current manages to leak through the insulation. And finally, based on how much, if any, current leaks out, it calculates the resistance. And you'll see these things being used absolutely everywhere. We're talking checking the windings on a motor to make sure they're not shorting out, testing the integrity of huge transformers and massive cables, even inspecting all the wiring tucked away inside electrical panels. It's all about making sure that powerful electricity stays exactly where it's supposed to. So, what's a good reading? What are you hoping to see? With a Megger, it's simple. You want a huge number, a really high resistance. The general rule of thumb is you want to see something above 1 megaohm. That's 1 million ohms. A big number like that tells you the insulation is rock solid. When you're using a Megger, higher is always, always better. All right, so that's the Megger. Now let's switch gears to our second tool, because this is where we start to build a complete picture of safety. It's time to meet the earthing tester. And if the Megger checks the raincoat, well, this tool checks the ultimate safety net. What this guy does is check the quality of your system's emergency exit. See, if something goes seriously wrong, a major fault, and electricity escapes where it's supposed to be, the earthing system is what gives it a safe path to travel straight into the ground. The earthing tester's whole job is to make absolutely sure that emergency exit is wide open and completely clear. And here's what's so interesting. Its process is basically the opposite of a Megger's. Instead of that high voltage, it just sends a small, controlled current through the grounding rod and into the earth. Then it measures the change in voltage, the voltage drop. And from there, it just uses good old Ohm's law to calculate how much resistance is in that emergency path to the ground. This is a super fundamental safety check. We're talking about validating the earthing for entire buildings, making sure the whole structure is properly grounded. You'll see it used at electrical substations where just incredible amounts of power are flowing, and of course, on huge industrial machines to make sure they have a safe path to dump any fault current. And listen up, because this is probably the single biggest difference between the two. Remember how with the Megger we wanted that massive number, millions of ohms? Well, with an earthing tester, you want the complete opposite. You're looking for a tiny number, ideally something less than 5 ohms. A really low resistance means that emergency exit isn't just a path, it's a wide open super highway to safety. For this tool, lower is always better. Okay, so we've met both contenders. Now it's time for the main event. Let's put them head to head and really lock in these differences once and for all. This chart really says it all, doesn't it? It just lays everything out plain and simple. They're basically functional opposites. You've got the Megger, checking insulation strength, using high voltage, and you're looking for a high reading.
Then you've got the earthing tester, checking earth resistance using low voltage, and you're looking for a low reading. They are absolutely two sides of the same electrical safety coin. And this really brings us to the most critical takeaway from all of this. It's never about which tool is better. That's the wrong way to think about it. It's all about knowing exactly what question you're trying to answer, and then picking the right tool for that specific job. Seriously, if you only remember one thing from this whole explainer, make it this. The Megger is asking a simple question. Is the protective coating strong? But the earthing tester is asking a totally different one. Is the safety path clear? See the difference? They are two completely different questions, but they are both absolutely vital. One is about preventing a problem, and the other is about protecting you when a problem happens. And that's really what it all boils down to. Choosing the right tool isn't just some, academic exercise for a technician trying to get a number. Understanding this difference is absolutely fundamental to making sure our electrical systems are safe for every single person who comes near them, from the electrician installing it to you, the person using it every day. So now you know the difference. But this whole thing leaves us with a bigger question, right? What other tools are out there, maybe even ones you use every day, where a small misunderstanding of what they're really for could lead you to a completely wrong and maybe even dangerous conclusion? It's a pretty powerful reminder to always understand not just how a tool works, but to really think about why you're picking it up in the first place.